Alright guys, so in the previous video we introduced implicit differentiation and how to carry out that derivative. So in this video we'll continue. When we have exponential function mixed up implicitly, how do we differentiate? So we take the question on the board for an example. We have xy squared plus exponential xy plus 3x to be equal to 0, and we are asked to find the y dx. So I've always said in implicit differentiation you treat both x and y to be a function of x, and as such you differentiate them both with respect to x. So we're still going to do the same thing here. Now I want to differentiate this function. First of all, I have xy squared. This is actually what product of two functions, x multiplied by y squared, so which means I'm going to employ the product rule to differentiate this function. All right, so first of all, I will differentiate with respect to x the whole of this function xy squared, plus I will also differentiate with respect to x the given exponential function xy plus d dx, this other function 3x, and that's equal to 0. I will have this. Now, since I have xy squared here, this is actually what the multiple of two functions, which means I'm going to employ the product rule. And to do this, first of all, you keep x as a constant. I'll have x. Then you differentiate y squared with respect to x. I'll have d dx of y squared plus, now I'll keep y squared as a constant. Then I'll differentiate x with respect to x. So I'll simply have d dx of the function x. Okay, so that's that for this derivative. Plus, now I have an exponential function. Please look up my video for shortcut approach on differentiating exponential functions, because we're going to employ that here. Okay, I have an exponential function here, exponential xy, and I'm to differentiate this function with respect to x. Now, I've done a video on that, on how to differentiate by shortcuts, but just to do a review of that video, to differentiate an exponential function, what you do is simply differentiate the power, use that power to multiply the exponential function itself. That becomes the derivative. So I have the power now to be x multiplied by y. So all I need to do is simply what? Differentiate this power xy, then use that derivative to multiply the exponential function itself. That gives me the whole differentiation. Okay, now to differentiate xy, of course I'm going to employ the product rule. So which means I'll keep x constant, differentiate y with respect to x, plus now you keep y constant, differentiate x with respect to x. Okay, you have this. Use this derivative to multiply the exponential function itself, exponential x y. That becomes the whole differentiation. So simply differentiate the power, use the derivative to multiply the exponential function itself. That gives you the whole differentiation. So you have that. Okay, plus, okay, plus now I am to differentiate, of course, 3x. 3 is a constant, you can pull it out. I'll simply have 3, and of course I'm differentiating x now, the x with respect to x, and the whole of this is equal to 0. So I simply have this. Alright, so this is now x into, if I differentiate y squared, I will simply have 2y, and of course since I differentiated y, it becomes what? The y all over the x, which shows that in this given expression I differentiated y with respect to x, so I have the y over the x, plus here is simply y squared, and of course differentiating x will simply give me 1, but then to show that I differentiated x with respect to x, I will simply attach the x all over the x, which is in fact what is here, d of x all over the x. Okay, plus now I can expand this bracket, or I can still okay, evaluate more. This becomes x dy all over the x, plus, and of course the y over the x here is 1. I'll simply have plus y multiplied by exponential x y, plus, okay, of course same here, the x over the x is 1, so I'm left with 3, plus 3 is equal to 0. Okay, so this simply becomes 2xy dy all over the x, plus I have here y squared, the x over the x is 1, plus, I can now decide to expand these brackets. Of course, x times exponential xy times dy dx simply gives me x exponential xy dy all over the x plus then y multiplied by exponential xy gives me y exponential xy plus 3, and this is equal to 0. So from here now, all I need to do is simply what collect like terms, let the y dx come together. I have the y dx here, I have it here as well. So we collect those two like terms and we simply have 2xy dy all over the x plus I have here x exponential xy dy over the x exponential xy dy all over the x plus I have here y squared plus y exponential xy plus 3 y squared y exponential xy plus 3, and this is equal to 0. So at this point is to factor the y dx between these two. I'll simply have 2xy, okay, plus x exponential xy all into the y all over the x plus y squared plus y exponential xy plus 3 to be equal to 0. So all I need to do is simply send the whole of this term, which does not contain the y dx, over to this side of the equation. That makes it easier for us to find the value of the y dx. So we simply have 2xy plus x exponential xy multiplied by dy all over the x, and that's equal to positive y squared cross equal to sign becomes minus y squared. Same thing here, minus y exponential xy, of course, minus 3. So you simply have this. So to make the y dx subject, divide all through by what? This variable attached to the y dx. Therefore, I will simply have the y dx to be equal to minus y squared minus y exponential xy minus 3 all over 2xy, okay, plus x exponential xy, and that's the final answer to that given problem. Okay, so that is how you differentiate implicitly when an exponential function is involved. And not forgetting the shortcuts to differentiate an exponential function, simply differentiate the power, use that derivative to multiply the exponential function itself, and voila, you're done. All right, guys, so let's try one more example before we call it a stop on this video. All right, so let's consider this other problem on the board. Of course, we're having the exponential function now attached to what? A trig function. We're seeing cos y over there. And of course, we are asked to find the y dx. So it's still basically the same rule that applies. Consider both x and y to be a function of x and differentiate both of them with respect to x. So which means I am simply going to differentiate with respect to x d dx of y cubed plus d dx of 2xy, which is this function here, plus d dx of the given exponential function exponential x cos y, and that's equal to d dx of x squared. So I have this. Okay, so of course, if we differentiate y cubed, use the power 3 multiplied by y, subtract 1 from the power, 3 minus 1 becomes 2. So I have 3y squared. And of course, since I'm differentiating y with respect to x, I will simply attach the y all over the x plus, now first off, 2 is a constant. You pull it out of the differentiation sign, and the next row I have x and y multiplying each other, so I have to simply employ the product rule to differentiate. From product rule, you keep x constant, differentiate y with respect to x, plus now you keep y constant, differentiate x with respect to x, so I have the x all over the x, okay, plus Now I have to differentiate an exponential function raised to the power of x cos y. And I said to differentiate an exponential function simply, first of all, differentiate the power, use that derivative to multiply the exponential function itself. That gives you the differentiation. Okay, so I have to now differentiate the power. The power is simply x cos y. That's the power of this exponential function, x cos y. So which means I'm simply going to employ the product rule of differentiation. Since the both of them are what? Multiplying each other, I'll simply employ the product rule. And from product rule, you keep x constant, then you differentiate cos y with respect to x. Okay, so d dx cos y plus, now you keep cos y constant, you differentiate x with respect to x. So have d dx, of course, of x dx, then use this value to multiply the exponential function itself. I'll simply have exponential x cos y, and this is equal to, of course, if I differentiate x squared here, I will simply have 2x. And of course, since I'm differentiating x, I will simply attach the x all over the x. And that is it. So let's evaluate, guys, and see. This gives me 3y squared dy all over the x plus, and of course, this is 2 into, this becomes x dy all over the x plus, here the x over the x is 1, so that's off. I'm left with simply y. So plus y, okay, plus, open up your brackets. I have here, if I differentiate cos y, I will simply have minus sine y. So that simply gives me minus x sine y, okay. And since I'm differentiating cos y, which means I'm differentiating y with respect to x, I'll simply attach here dy all over the x, okay, plus, of course, here the x over the x is 1, multiply cos y simply gives me cos y, okay. You put down your exponential function, exponential x cos y, and this is equal to, over here, the x over the x is 1, so times 2x, I'm left with 2x simply here, okay, equals 2x. Okay, so I think I can expand this bracket now. I'll simply put down here, this is 3y squared dy all over the x plus, I can expand the bracket with 2, so 2 times everything here gives me 2x dy all over the x plus 2 times y gives me 2y. Same thing here, minus x sine y dy dx multiply exponential x cos y. That gives me minus x exponential x cos y sine y dy all over the x, okay, plus cos y multiply exponential x cos y. That gives me exponential x cos y times cos y, and this is equal to 2x. So I have this. So at this point is to collect like terms, bring all the dy dx terms together, bring all the dy dx terms together. Of course, if I do that, I'll have 3y squared dy dx all over the x plus, I have here 2x dy dx, 2x dy all over the x. I also have here minus exponential x cos y sine y dy dx minus x exponential x cos y sine y dy all over the x. Okay, so I'll put down these other terms now. I have here plus 2y, and I have here exponential x cos y. So plus 2y, pardon me, I'll take it down a bit, plus 2y plus exponential x cos y and this is equal to 2x. Okay, let me just cross check. All right, so I think we're in order. All right, so at this point is to factor the y dx. The y dx is common here, so you simply factorize. I will have here 3y squared plus 2x, okay, minus x exponential x cos y sine y, all multiplying by the y all over the x plus 2y. Okay, pardon me, I'll take it down again, plus exponential x cos y, and that's equal to 2x. So at this point, it's simply to send 2y, and of course, this variable exponential x cos y over to this side of the equation. If I do that, I'll simply have 3y squared plus 2x minus x exponential x cos y sine y, okay, dy dx, and that's equal to, it becomes 2x minus 2y, okay, minus, sorry, I'll take this down again, exponential x cos y times cos y. Okay, so I have this now. Pardon me for this, please. At this point, to make the y dx subject, of course, we have to divide all through by this variable, divide the whole of this variable by the variable attached to the y dx. So I think we can do that over the other side. And if we do that, we are going to have that the y dx, okay, is now equal to the whole of the variable here, which is 2x minus 2y minus this, okay, 2x minus 2y minus exponential x cos y multiply cos y divided all through by, okay, the whole of the variable here, 3y squared plus 2x minus x exponential x cos y, 3y squared, okay, plus 2x minus x exponential x cos y multiply sine y, okay. So let me cross check that a bit. All right, so I think, yeah, I think we're in order. So that becomes the final answer to that given differentiation. All right, guys, so that's how you carry out differentiation of implicit functions involving exponential functions. So in the next video, we are going to talk about implicit function involving trigonometric functions, and of course, if possible, logarithmic functions. So stay connected. I will see you in the next video. Please, if you're new to the channel, don't forget to tap the subscribe button, and of course, if you have any questions at all, post on the comment section, or you can hit me up on WhatsApp, and I promise to respond to all your questions. Thanks and cheers.